we are prepared for questions. That's what we're trying to say.
We're prepared for questions, we're prepared for discussions, we're prepared for feature requests.
You already got one today.
I already got one today, yes. It's really, really rare that I talk to a team that uses Priebsch on a daily basis and not get out of the discussion with at least one feature request.
And those are for testing evil and ugly legacy code then?
Usually, but not today.
That's good.
Okay, so these slides will be on talks.thephp.cc. You can reach both of us at the team at thephp.cc. We are also on Twitter. And we didn't really introduce us in the beginning. We only said that there's a knight and there's a wizard. I don't know if I'm a wizard, but
well, in World of Warcraft, I believe you are.
I'm not allowed to play neither my mage nor my warlock at the moment. I have to play the priest. But that's what you do for your build. Okay. So we didn't do any marketing.
Yeah.
So what we do, we help PHP development teams on a regular basis build better software that is sustainable, testable, delivers business value every week, which is a really awesome thing to do. But we are also launching something new next year. At least in English it's new.
Yeah. And I'm not saying I'm growing tired of traveling, but my sofa is very comfortable back home, so we figured that we just write down what we have taught to the teams over time and sort of come up with what we call PHP curriculum. It's going to be a new PHP certification. Feel free to visit the phpcurriculum.com. You can get a free sample, and we'll collect your email and spam on you forever. So just go ahead if you're interested. And that's all the marketing you're going to get. And we'll open up for questions. Thanks for listening. So if you have any questions, I would ask you to sort of come up.
So in application, you can use like models, right, to interact with database. And yeah, well, okay.
Don't spoil Stefan's evening.
Okay, so and somehow you need to test this code, right? So like two approaches is just use like mock objects all the time for all methods where you can work with these models. Or can actually use like DB unit, for example, to actually do the request to get response. And the reason why it will be really hard to maintain code, if you have calls to this model in multiple places, maintaining these like mock objects might be really difficult if models changes relatively fast, often, right? On the other hand, keeping all those like fixtures for DB unit tests, it also might be a problem when you have to kind of like, if schema changes for some reason, right? You have to redo all these like fixtures that you might have like a lot of them. And maintenance, it's also kind of the problem. What would you recommend as like better approach to handling this the test? Thank you.
So first of all, since I was yelling, models have nothing whatsoever. That's the ideal world now. Models should have to do nothing whatsoever with database access. Models are, in the common perception of MVC, which I don't think exists on the web, but anyway, are where you put your business logic. Okay, and now Ruby on Rails has made the active record pattern rather popular, which puts business logic and data access into one object. Having stuff in one object, that's a very tight coupling. That's stuff that belongs to two different layers of your application. So basically you're creating a two-layer application that has a presentation layer and everything else layer. This leads to the problem that you will not be able to test your database or test your business logic independent from the database. So move all that data access stuff out of the model. Then your model purely contains business logic. The model does not care about where it comes from. It's just there if you need it. Let's work under this assumption. Then you can write tests for your business logic completely independent of any data source. You just instantiate your business object, initialize it as you need it, run your test, and throw it away. That's what PHP unit does to you. So at some point you'll have to test database access. That's for sure. That's usually a class, maybe a table data gateway-like thing that sits on top of one database table. If we're talking about a relational database, then exactly that's where DB unit comes into play, which in essence allows you to set up a database fixture, modify the database, and then have PHP unit assert that the database is in the state that you expect it to. And then again you throw the database away. Ideally, you use some SQL-like in-memory thing to keep it fast. But this is a generic test. You have your gateway, and sort of there's a method to store an object, okay? And we are assuming that if that works for one mock test piece of business object or the data that it contains, if we manage to write this one record to the database, and DB unit tells us this has worked, then we'll assume that this also works for all the other cases. So it's sort of by breaking down your tests in smaller pieces, you can test some parts generically. You don't have to test that writing 100 different business objects works. You just test one. Obviously, you can still fail on that. If you come up with a weird way of creating SQL statements, so you get this invalid statements or injections or whatever, so you might actually want to be using a data provider that writes different sets of data to the database to see if that works. So the nasty tester usually comes up with a name like Matthew Weir Ruffini, because that has this apostrophe, and that's SQL injection, dangerous kind of thing. And if that still works, then we might be rather safe. So I think the key is keep business logic separate from data access, and then test everything in a really, really small scope.
Talking about scope, it's really important when you're testing code that interacts with a database and use DB unit to keep the fixture as small as possible. I've seen many teams trying to use one big fixture for all tests in a test suite that interact with the database. And it's a performance overhead and a maintenance nightmare. Because when one test changes, you have to look at the whole fixture, make sure that everything still works, it's updated. Make the fixture as small as possible as you can get away with for the one test that you're testing.
There's another aspect that's interesting to testing database access code. In theory, we're just talking about a string, which is a SQL statement. And a SQL statement is a functional program. It tells the computer how to write data or how to retrieve data without telling it what exactly to do. So it's basically a functional program. Now that string, you like to disagree with me. Okay. So that string can either be a valid or an invalid SQL statement. And how do we find out that? Pretty much the only way is to ask the database to process the statement. And the database is going to tell us whether or not things look all right. Why do you disagree with me?
Because it's declarative, not functional, what you're referring to. Functional is just a different flavor of imperative programming.
Usually he's right with that kind of stuff, but we'll discuss that on the video. Okay, further questions?
My question is, can you talk about the feature request that you received today?
So the feature request I received today deals with what's called flaky tests. Like you have a big test suite, and you run the test suite, and one test fails. And in that case, so the feature request was, when a test fails, try to rerun it. And if it passes, mark it in a certain way it has passed, but there was something fishy about it. And this will probably be configurable so that you can say, okay, if a test fails, try to run it 100 times or 10 times or whatever your level of paranoia is. And if it passes more often than it fails, then it will be marked as sort of passed. I don't know what name this kind of will have in the test result, because F is already taken for failure, so I cannot use flaky or fishy. So the biggest part in implementing this feature request will be coming up with a name for how I can display that in the test result. Because implementing the feature itself is not going to be that much of an issue.
I can give you a good example for a flaky test. I was working with a customer a while ago, and they had code that would create a timestamp. So that's a now. And then in the test, they would retrieve the timestamp and compare it to create current timestamp. And I said, guys, this sort of works sometimes, but you have no guarantee that it works, because if the second flips between the time when you create the first timestamp and the second, then the test is going to fail. And while I was talking to them, I was hitting the up arrow key, hitting enter to rerun the test suite, and we saw the test fail. So that's a good example, simple example for a flaky test that sometimes just fails. Usually works.
A unit test, a test that tests one unit of code in isolation from all of its collaborators in external systems, should never be flaky. Flaky should only be an integration test that interacts with some sort of randomness or time information or...
You remember the customer where we wrote the ugly UUID code? That's proving wrong. So we once consulted with the customer and created sample code and said, okay, you're going to have a UUID, and there's a standard for UUID, but we're not going to implement the standard right now, so we're just going to use a simple unique ID PHP function call. And then we were paranoid and actually created a test that made sure that when we create two UUIDs in sequence, that those are different. And as we did that, I said, that's sort of paranoid. And it doesn't guarantee that UUIDs are really unique, but, well, it's not really a big deal to write the test, so we just added it. A couple of weeks later, we get an email by the customer saying, hey, I have a problem, because this UUID test randomly fails. And I can't really reproduce it. It's every once in a while. So there was a flaky test. What was the problem? We had those UUIDs starting with a number and followed by an E, which PHP would not interpret as a string, but as an exponential number, yielding the comparison nonsense. So that's a nice example for a flaky test out of stupidity or maybe out of laziness, because we actually added a comment that this is just a temporary UUID solution, you should change this, and they did it. You got the code here?
I have code from one of my projects that I started when I'm bored on the flight or on the train ride. This is code I wrote a really long time ago. Let's take this.
And? So level of paranoia means how many times are you going to repeat the test to make sure that you get different UUIDs, right?
Yes. So by default, the paranoia level is 1. If you want to be really paranoid, then you can be paranoid.
So, how do you test PHP unit?
So that's actually one of the most common questions that I get at the end of a presentation on PHP unit.
He rolls it out. No, that was a joke.
Yes. So the honest answer to that, I use PHP unit to test PHP unit. That's what all the other test frameworks do. But there's also plenty of tests written in PHP, which is the testing tool that the PHP project uses to test the PHP interpreter. And I use PHP for end-to-end testing of the PHP unit command line tool. So the PHP unit framework itself is tested with PHP unit. The command line tool is tested through PHP. And the only reason why PHP unit or the PHP unit command line test runner is able to also execute PHP tests is because I want to have PHP unit and PHP tests for PHP unit itself in the same test suite. Don't use PHP for your PHP code. It's meant for testing the PHP interpreter. And I'm abusing it for testing PHP unit. Okay, thank you.